I need a calculator.
So what we're going to start with is that there's a connection between powers and roots. I've already taught this to you in a sense. Okay, for instance, if you had the square root of x to the 50th, tell me what that is. X to the 25th, right? Okay, there was a little trick to that. Remember, the reason it's x to the 25th is because if you multiply your answer out twice, you would get back to the beginning, right? So what you find is if you did like the square root of x to the 30th, what would you do? You just do half the exponent, right? So it turns out when you do a square root, that's the same thing as the half power. Maybe you've seen this before, maybe you hadn't, but you can take a number and raise it to a fractional power. You can. It has a mathematical meaning. So there's a couple things you want to write down. If you have, in general, if you have an nth root of x, that's the same thing as x to the 1 over n. Okay? So if you have a 1/2 power, that's a square root. If you have a 1/3 power, that's a cube root. And if you have a 1/4 power, that's a fourth root like that, and so forth. So if you had a 5th root of x, that is x to the 1/5 power. That's what it means. Okay? Maybe you've seen that before, maybe you haven't. But that's the idea that we're going to establish is what fractional powers mean, because they do have a mathematical meaning. Okay? So when you're working these problems out, to begin with, this is what you're going to do. When you see a 1/2 power, you want to know that immediately what that is that's a square root. Okay, that's what that means. So what's the answer to this problem? 7. The square root of 49 is 7. Agree? Okay. Don't get your calculator out on a problem like this. Understand that it's a square root when it's a 1/2 power. Okay? Next problem, we do this. Now you're going to have 81. Which root are you going to do? Fourth root. Fourth root of 81, you're looking for a number that you multiply out 4 times that will give you 81. Use your calculator if you need to. What you would get is 3. So the answer to that problem is 3. Okay, so if you multiply 3 out 4 times, that's what you're going to get. Okay, everybody solid with what I've done so far. Okay, I'm going to skip number 4, but come back to it. Okay, I'm going to just push on with this next one here, this number 5, but then I'll go right back to it. Okay, what this would mean is it's a 1/3 power, so what does that mean? It's a third root of 1 over 512. Okay, so what you would do then, anytime you have a fraction, just do the third root of the top, and then do the third root of the bottom like that. The third root of 1 would be what? 1. 512, you'd have to either get your calculator or play with it. Like if you did 6 times 6 times 6, that doesn't work. I don't, or maybe no. 7, 8. I think it's 8. Okay. Yeah, and what you can do on your calculator too is you can just try something like if you think it's 8, you just go 8 to the 3rd power, and then that'll give you 512, say. Okay. So you can kind of work backwards when you do that. Okay. So that would end up giving 1/8 as your answer to the problem like that. Okay. So that's the idea, is you're learning how to rearrange these things into radicals. Now the next one, watch this very carefully because there's a tendency for students to not understand that negative. This is a real common problem students have. So first of all, a 1/5 power is going to be a what? A 5th root, right? Okay. Now the question is what is being raised to that power? Here's the thing. 243 is going to go under, the negative is going to go there, and let me explain why that is. And one thing that you definitely want to write on your paper to help you understand this is I want to give you a slightly different problem. I want to give you negative 243 to the 1/5 power. Write that down, do that, that's important. Write that down where the negative 243 is in the parentheses, okay? If you did this problem instead, then it would be 5th root with the negative 243 under the radical. Now that's incredibly important in mathematics. Whenever you have an exponent, if this is not in parentheses, then that negative is not a part of what's being raised to that power. So you must, if you leave the parentheses off, that negative means that the negative of that radical. But if it's in parentheses, that's why we use parentheses. That'll tell us that that's under the radical. Does that make sense? Okay. Here's something else I just want you to pay attention to, because a lot of times students don't know this. If you had negative 2 to the fourth and negative 2 to the fourth, those problems are totally different. Totally different. If you do this problem, since that's in parentheses, what that means is you multiply that out 4 times and you would get 16. That's the meaning of that. But if it's not in parentheses, this means you're multiplying 2 out 4 times, but then you're just attaching the negative, so the answer to that's negative 16. Okay? Students a lot of times don't know that. Okay, and that's something that's incredibly important to know, is how we use parentheses and radicals in exponents. Does that make sense? Okay? Pay attention to that, because if you fall for that, you're going to get the wrong answer. Okay, 243. If you did the fifth root, you would find that 3 times 3 times 3 times 3 times 3 is 243. So the answer to this problem is going to be negative 3. That's it. Okay? All right, good or bad? Everything okay? Okay? All right. Now, pay attention to what I just taught you on this. Okay, you know a 1/4 power becomes what? A 4th root. Everybody solid with that? Now, the question is, what goes under this thing? Would it be the x? Would it be the 8x? Tell me. Just the x. Just the x. That would have to be in parentheses. If you don't have parentheses, then the thing directly below it is going to go under the radical. That 8 does not go there. It goes there. Okay? That's incredibly important. So you want to write that like that. And then you're not going to do anything with the problem. You're just learning to write that. Now, I would also suggest that everybody write this problem down too. That's a different problem. It's the grouping 8x to the 1/4 power. Now, you would have a 4th power. On this problem, tell me what goes there. The whole thing. You guys seeing what I mean by these parentheses? You got to pay attention to that. Parentheses are very important in math. Now, we don't work the problem out because we don't know what x is. Okay, so that's the idea. Okay, let's do the next one. What do you do with a 1/2 power? What does it become? Square root, 2nd root. Now, tell me, what goes under the radical? Is it just the x to the 10th or is it the whole thing? Whole thing, because of parentheses. Good. Okay, so what you'd have is 81 x to the 10th. Now, can you tell me the answer to that problem? You can work that out. 9 x to the 5th. You're doing half of the exponent. That's what a square root is. You're doing half of the exponent. So that's 9x to the 5th. Okay, so I'm going to let you all work on the next 5 problems. I'll walk around and see if you know what in the heck you're doing.
Is 6x or 8x?
What's that?
Is the answer to 6x or 8x?
The answer to number 6 is this right here. That's it.
Oh, okay.
Okay. What I was saying on that is there's no parentheses, so
yeah.
4th root of x. The 8 is separate from that. Doesn't have anything to do with it. That's because it's not in parentheses. Okay. That's an important thing I want to make sure everybody has well under control. And don't forget it. Okay, so I'm going to do this real quick. Just check your answer. I didn't see hardly any problems. This one is root 144. Answer is 12. Next one's 4th root of 16. Answer is 2. Okay. I do want to show you something real quick too. When you're doing your homework, please don't get your calculator out for every freaking problem. You won't learn anything. But it's good to know this. If you do 16 raised to, you'll have an exponent. And if you actually did 1 divided by 4 like that, your calculator will let you put 16 to the 1/4 power in and it'll give you the answer. Do not do your homework that way. Do it the right way because you're not going to learn anything that way. Okay? All right, but you can do it to check. I don't care if you check. That's fine. That's great. Okay, this one was good. This was one of the ones I was looking for. So you have the 5th root. Tell me what went under the radical.
32.
Just the 32. Where'd the negative go? There we go. Good. I think I saw just about everybody get that. That's outstanding. 5th root of 32 is 2, but then the negative reattaches. So the answer is negative 2. That's how you handle that. Okay, next one is the square root of 1/16. It's a fraction. What did you get? 1/4. Good. Next one, you have cube root. What goes under the cube root? The whole thing, because it's all in parentheses, right? So hopefully you did that. to have that. Now you can get the answer of the problem. Okay, what's the cube root of negative 27? Negative 3. What do you do with the 15 and 3? Just divide them. Okay, so that would be negative 3x to the 5th. That's it. These problems are not hard to do because it's mostly arithmetic. Partially you're learning the language of how the radical goes. Okay, let's move on to the next thing. So we're going to learn a kind of an extended property out of this. So I'm going to show you what this property right here says. Write down this example. Let's just say that we have x to the 7 over 3. You can take a number and raise it to any power. Turns out that that's the same thing as the third root of x to the 7th. Okay, if you're going to take calculus, and I know a lot of you will because a lot of your STEM majors, then you work with rearranging this all the time. Just second nature if you're in Calc 1, you do this constantly. Okay, so the idea is that's how you change that. One more example, if you had like a number like 2 to the 7 over 9, that would be the 9th root of 2 to the 7th. Okay, whatever the denominator is, that's the name of the root like that. So that's the first thing that you got to do on now. Okay, so these problems here, you want to do these problems we're getting ready to do without a calculator, but you could check them on your calculator super easy. So here's what I want you to do. And you need to learn how to write this two ways. It's important. So the first thing is, the 3 is what the root is. Whatever the denominator is the root. So that would be third root of 64 to the 4th power. Okay? Now, what I'm going to do is I'm going to show you two ways to do this problem. Okay? One way you'll be able to probably do in your head mostly. The other way you'd probably need your calculator on. So you could do this if you wanted to. This is not the way I would do it though. You could take your calculator and you could do 64 to the 4th power. Well, let's do that. Why not? Okay, let's write down that we have the third root of 167777216. Okay, then we're going to have to turn around and do the cube root of that thing anyway. Okay, so now I'm going to take my calculator. No way I know that in my head. So I'm going to go math. I'm going to do my cube root button on my calculator. I'm going to do the cube root of 167777216. Well, let's see what I get. My God, I got 256. There's got to be a better way to do that problem. In fact, there is. That's what I'm going to show you. If you want to do the problem that way, you can, but if you do it that way, you're going to have your calculator. Okay? So here's the best way to do it like this. Okay? So it turns out that what you can do is when you change this, you can go cube root of 64, but instead of putting the 4 under the radical, you can just do the whole thing to the 4th power. That's the way you want to do these problems. It's generally better that way. Okay? Same thing. It means the same thing. Now, most of this you'll do in your head. Can you tell me what the cube root of 64 is in your head? 4. Yeah, that's not too bad. Okay? So that means that's going to give you 4 to the 4th. And then you could do that on the calculator. So if you did 4 to the 4th on the calculator, or by hand, you would get the same answer. Isn't that better? Okay, to me, you don't even have to worry about that big number. Just do it that way. That's the way I'm going to focus on doing the rest of these, is train you to do it that way. Okay? Okay, next problem. Let's do this like this. So what are you going to have? You're going to have what root? Is that going to be a 4th root or 5th root? 5th root. Okay? Then we're going to have the 243 to the 4th power, but instead of doing it that way, do the 5th root of 243, the whole thing to the 4th power like that. It's better that way, in my opinion. Okay? And once you practice, you'll get to a point where you start memorizing some of these. You really will. Okay, do you know what the 5th root of 243 is? We already did that today. It's 3. If you don't know, work it out. Okay, so that would be 3 to the 4th. 3 to the 4th you can do in your head. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. I didn't need to touch my calculator. Okay, does that make sense? All right. Okay, next one. Tell me what the root is. Third root. Okay, so you would have the third root of 1 over 27 raised to the 2nd. That's the first step you do that. But instead, write it this way. Cube root of 1 over 27, the whole thing squared. Okay, everybody solid with that? Okay. I want you to do this in your head. What's the cube root of 1 over 27? 1 over 3, right? Okay. So what you have then is you have 1 over 3 to the second power. Can you do that in your head? 1 over 9. Okay. What you're doing is you're doing a third times a third. Multiply straight across. You get 1/9 like that. Arithmetic. Everybody following okay? Okay. All right. Next one. What's the root? 3. Okay. Now, notice you have a parenthesis there. So that means that that whole thing with the set of parentheses too is going to be under the radical like that. Okay. So it's got to go like that when you do that. All right. Now, what you can do on this one is you can, again, write it like this. You can do the third root of negative 64. Then you can raise the whole thing to the fourth power like that. All right? And the parentheses are important. If those parentheses were not there, that negative would be outside the radical like I taught you. Okay, can you tell me what the cube root of negative 64 is? What? Negative 4. Okay, you do a cube root of a negative, you get a negative. Okay? Watch this carefully. You absolutely have to keep that negative 4 in parentheses. You must. Because you're wrong if you don't. Because it started with parentheses, you got to retain that. Now, we're going to take the result of what I highlighted in blue and raise it to the fourth power. What's going to happen if you multiply a negative out 4 times? What are you going to get? Positive or negative? Positive. Okay, if you do negative 4 and multiply it out 4 times, you are going to get 256. Use your calculator as needed. Okay, what do you think? Lots of excitement is being generated by this, I can tell. Okay, all right. Okay, next problem. Okay, what's the root? Okay, now, it's in parentheses, right? So that means that what goes under that is parentheses 7x to the third like that. Now this problem, you don't know what x is, so you're not going to do much to this problem. What you're going to actually do is you're just going to do this. You're just going to do, like, let's do 7 to the third on your calculator. I think that's 729 or something. So if I do 7 to the third, 343. See, look at me. Okay, I'm a slacker. Okay, so that is 343. And then we have x to the third. Just write it that way. You can't do anything with that problem, though. If you did the 8th root of 343 on the calculator, it would have decimals, okay? So you just stop at that point like that. So if you're ever in doubt, again, on my graphing calculator, if I do the 8th root, I go 8, math, option 5, and then 343. Now, here's what will happen. I got decimals. I don't want decimals. If it doesn't turn out to be a nice whole number, don't even go there. Yes?
I'm sorry, how did you get 343?
Okay, what I did is I did this right here. I did 7x times 7x times 7x. 7 times 7 times 7 is 343. Okay? That's it. X times x times x, x to the third. That's what you did. Okay? Okay, next one. We're not going to do much with this one, but tell me what the radical is. What root? 10th root. Tell me what goes under the radical. Just the x. Outstanding. That sounded beautiful. Where does the 7 go? In front. That's it. That's all you do. The purpose of that problem is to make sure you understand how parentheses go. If the problem was 7x to the 3/10, then what would it be? 10th root of 7x to the third. That's it. And you wouldn't have to go any further with that if you don't want to. That's the idea. Bring down the what? Right here? Oh, on the first one. Yes, 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 yes. Thank you. Yeah. Okay, good. All right. All right, let's go to the next thing. I'm going to do this one, let you do a round of problems, then we're going to get into properties of exponents. Problem like this, you don't know what x is, so you're not going to do much with it. You're going to write this as a 7th root. Now, what's left is in parentheses, so you're just going to say 3x plus 1 to the second. And that's all you got to do. The other thing you could do is you could write that out twice. That kind of looks like FOIL, doesn't it? So you could do 3x plus 1, 3x plus 1 FOIL, but you don't have to. You could leave it alone like that if you wanted to. Okay. So let's go ahead and work these problems out. Let's just kind of together go through and set up the first one. When you do the first one, you're going to do cube root of 8 to the 4th. It's better to put the 4 outside, then work it out. Okay? Then let's set up the next one, and the rest of them you're on your own. But finish them up. So this one you're going to do like this. You're going to do third root of what's in parentheses, 8 over 27, and then the whole thing gets squared, like that. So step 1 is write it correctly. Step 2 is work it out. Okay? Let's take a few minutes and see if we can do these okay. Then we're going to do a little review of exponents. Try to do it in your head too, if you can. I understand you may get into some big numbers. If you do, get some help with your calculator. That's good. Good. That was good. Okay, that's good. You're doing fine. Pretty good. But when you do that, just kind of focus on that first. The cube root of 8, get the answer, then do the 4th power. You do that one, do the cube root of 8 over 27, get the answer, then do the second power. Good, you got the first one there. Is that a 4 over 9? Okay, you're good. You're fine. Okay, when you square that, 2 times 2 is 4, 3 times 3 is 9. That's it overall. That's not even a unique mistake. There's like the 10,000th student that over the years that's made that mistake. I even make that mistake sometimes not paying attention. So when you do this, you do that first. If you do the third root of 8, that's 2. Then 2 to the 4th, you work that 2 times 2 times 2 times 2 4 times. So work the cube root out, then raise it to that power. You want to do it in that order. Okay, that looks good. All right. That's fine. That looks good. That's good. That's good. All right, you guys doing okay? As long as you can do the first step okay, that one be positive. And the reason for that is because when you do that cube root, you're taking -3, the whole thing to the 4th.
Okay.
That's why. You gotta be real careful about those parentheses.
Thank you.
Okay, let's run through these and we'll get into our exponents. Okay, so when you're doing this problem, you should have started by doing what I highlighted. That is 2. 2 to the 4th, you can do in your head. That just means 2 times 2 times 2 times 2. Answer is 16. Everybody's got that okay. Next problem, you do the cube root of the fraction. The cube root of the fraction was 2 over 3, and then you're squaring the whole thing. Okay, once you do that cube root, then you want to have that parenthesis, because see, that parenthesis is still there, then the whole thing's squared. That's 2/3 times 2/3, so you should have got 4/9. I think we're okay with that one. Okay, next one is a little tricky with one thing. You're doing the cube root. You have a parenthesis, so you want to write that as like this. You can either write it like this to start with. Then you probably would be wise if you just wrote it like this. You're doing the cube root of -27, but the whole thing is to the 4th. Okay, watch out on those negatives in parentheses because it's real important. Okay, what is the cube root of -27? -3, right? Okay, now I'm going to take that to the 4th. See how I left the parenthesis? So you're multiplying out 4 negatives. What do you get, positive or negative? Positive. Multiply it out, you should have got 81. Not -81, positive 81. Is that good? Okay, next problem. This nothing to do on this one. It's just 7th root, 5x plus 3 to the third. You can write it that way and stop. You don't have to multiply that out 3 times. You can if you want to, but there's no sense in doing that. Or you could write the answer like this. You could say 7th root of 5x plus 3, the whole thing to the third. There's nothing else you can do with that, though. That problem, since there's an x in it and a variable, you don't work it out, you just write it. Does that make sense? Everybody good? Okay. All right, next thing we need to do, and students a lot of times in this class don't know all of their exponent properties very good, although we've done some of this semester. I'm going to review several of these properties of exponents, and then we're going to start working with some algebraic problems where we're simplifying things with fractional exponents. Okay, the addition property, we've done this like all semester, over and over and over again. What it says is if you have a multiplication problem, the bases are the same. The bases are these things I'm highlighting. Then what do? You write the base, you add the exponents. This is something that's not new to you. Let's write down just a couple of examples. Say you have x to the third times x to the fourth. That's the kind of problem we do. What's the answer? X to the seventh. Bases are the same, write it. Add the exponents, do that in your head, you get x to the seventh. Okay? When you're a math student and you're in different classes, you're going to forget things, so you always need a strategy to figure something out. The meaning of this problem is extremely easy. X to the third just means 3 x's, right? Multiplied. What does x to the fourth mean? It means 4 x's. How many x's did I write on my paper? 7. Okay? Addition is a shortcut for counting. I don't know if you've ever thought of that, but that's what it is. Human beings knew how to count before they knew how to add. Okay? So it's a shortcut. All right? Next property is this. We've actually looked at this today, but we haven't done this much this semester. So if you have a set of parentheses, write this example down. Let's say you have x to the third, and then you're taking that to the fourth power. You have 2 exponents. You have something in parentheses, and then something outside. You do not add the exponents in this case. You multiply them to get x to the 12th. So you've got to know which rule applies, how to do that, and the y part. Okay, let's write something down on this y part. Okay, if you have x to the third to the fourth, let me explain what this problem really means. It means that you're taking something to the fourth power. And when you're taking something to the fourth power, it means that you're multiplying something out four times. Agreed? That's what a fourth power is. Now, what are you multiplying out 4 times? Well, you're multiplying out x to the third. That's what the mathematical meaning of that problem is. Now, you guys tell me, do you see, I didn't write down 12 x's, but do you see they're there? Absolutely. There's 3 there. 3, 3, 3. You know what multiplication's a shortcut for? Repeated addition. So what would happen in this problem is you would really be doing x to the 3 plus 3 plus 3 plus 3, but isn't 3 plus 3 plus 3 plus 3 just 3 times 4? Okay, that's why humans invented multiplication, is because they got sick of adding over and over again. It's a shortcut. That's the idea. So that's why you do that. Okay, we've seen this one before. We've done this semester in different problems. So if you had something like, say, x to the 6th over x to the 2nd, okay, what you do is you subtract the exponents. Now, the bases have to be the same. If that was an x and y, you can't do anything. Okay, so this would just be write the base, subtract the exponent, you have x to the 4th like that. That's the idea. Okay, here's the y. We have seen the y this semester. If you had x to the 6th over x to the 2nd, here's what it means. X times x times x times, I know I'm doing this fast, x times x times x, blah, 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 like that. What happens? They cancel. 2 of them cancel, leaving you 4. But you always want to know where this stuff comes from because it'll stick with you better. If you just say, oh, this is a rule, I don't know why, you'll forget it. And you'll forget it today. Okay? All right? The other thing is anything to the first power is itself. We haven't looked at this, but anything to the 0 power is 1. I'm not going to go why that is today, but if you had something like 7 to the 0, that's 1. There's a reason for that, but I'm not going to get into that, okay? Okay, next thing I want to look at is, well, actually, I am going to explain it. I forgot. I'm going to explain it on the next thing here. Because a lot of times students don't know these things, but in math is the study of patterns. This is pretty cool, too. If you did 10 to the 4th and 10 to the 3rd, that would all, you could get these answers, right? What's happening on this? We're going through 4th power, 3rd power, 2nd power, 1st power, 0 power. So this is the way mathematicians started thinking about what something to the 0 power means. Look what's happening. You're just getting 1 less 0, so it's got to be 1. If it follows the pattern, something to the 0 power has got to be 1. That's one way to explain that. Does that make any sense? That's kind of a cool way to explain that, actually. Okay, negative exponents. We haven't really done much this semester with this, so let me explain this. First of all, if you have a negative exponent, you can do that. Let's write down this one example. Let's say that you had 3 to the negative 2. Or even better, no, let's keep it at 3 to the negative 2. What that is it means 1 over 3 to the positive 2. That's what negative exponents are. And then if you worked that out, that would be 1 over 9 like that. Okay? If your negative exponent started in the bottom, write this example down. If you had 1 over 4 to the negative 2, that is the same thing as 4 to the 2nd. What happens is if you take a negative exponent, if you move that to the bottom, that exponent sign changes. If you take that and move that to the top, its sign changes like that. Now I'm going to show you something on the calculator real quick on this. Okay, I don't want to go into too much depth on this, but if I did 2 raised to the negative 2 power, okay, students a lot of times think the answer is negative. No, it isn't. If you take 2 to any power, it's always positive. Well, I'm going to get the answer on the calculator and I'll see if this makes any sense to you. So what I just did was I did 2 to the negative 2, the calculator spit out 0.25. Here's why. What this really means is 1 over 2 to the 2nd, right? That's what a negative exponent means. So isn't that just 1 over 4? Isn't a quarter 0.25? That's what the calculator is doing. So if you take a number and if you raise it to any negative power, you're not going to get a negative answer. You're going to get decimals, okay? One thing that you probably know from your background, like in scientific notation, if you had something like, and I don't know if this is right or not, but like the mass of an electron, you learn this in chemistry, is like 1.6 or sometimes 10 to the negative 19th. That just means it's a tiny number. It's not negative, it's just tiny. That's what it means, okay? So that's kind of a little review on that. Here's the why of how negative exponents work. It works through a nice pattern. So notice if my powers, once we go down from the positives, what has to start happening is these things have to start being divided. What's happening on this is this. If I do 100 divided by 10, I get, if I go through and keep dividing like this, I'm going to keep getting the same answer and over again. So if I did 100 divided by 10, I get 10. If I do 10 divided by 10, I get 1. If I do 1 divided by 10, I get 1/10 and so forth. So that's how the pattern goes on exponents. Does that look kind of fairly logical to you? Okay. So negative exponents are just tiny, smaller and smaller numbers is what they are. Okay. So to finish up here, I want to work a little bit with some properties of exponents. Let's just wrap up the negative exponents and kind of talk through what you need to learn how to do. If you see you have a negative exponent, the first thing that you need to learn how to do is write this as a positive exponent. So in this problem, you would go 1 divided by, or 1 over, 243 to the 4/5. That's step 1, is to write it as a positive exponent. Now the rest of the problem is what I taught you today. So what you would do is, if you do a 4/5 power, that would be the 5th root of 243, and then the whole thing to the 4th power. That's what you did a few minutes ago, right? So if it's a negative exponent, move it to the bottom, and then work it out. Okay, here's what you would do to finish this problem. The fifth root of 243 is going to be 3, right? And then you would do 3 to the fourth. If you work out 3 to the fourth, you get 1 over 81. Okay, like that. Okay? Now that's the way I want you to work the problem is arithmetically, try to not use your calculator much at all like that. Okay, you guys see what I did? Okay, all right? So when you have a negative exponent, that's what you want to do. Okay, this thing on this that's so important on this problem is notice that the negative is not in parentheses. We're going to do 2 problems so that you'll have something to compare to in your notes. So what we do on this one is we say 1 over 8 to the 4/3. Again, you move that 8 to the bottom, that makes the exponent positive, but that negative is just there. Okay, it's not a part of that 4/3 power like we talked about earlier. Okay, it goes like that. Okay, now if you work this out, you would have negative 1 over the cube root of 8, and then the whole thing to the 4th power like that. That's how that problem has to be put together, like that. Okay, then what we would do is we could finish this up. What's the cube root of 8? 2. So you'd have negative 1 over 2 to the 4th. And then 2 to the 4th is 16, so that's the answer. Like that. You have to do that in that order, and you have to pay attention to that negative, okay? Now, I would like everybody to also write this down. Seriously, write it down, because I don't want you guys to mess up with these parentheses and negatives. You need to get this down now. So what you would do at this problem is you would go 1 over, now it would be negative 8 to the 4/3. See the difference? What I'm doing with this again is if it's not in parentheses, the negative goes there. That's not a part of anything. But if it's in parentheses, it goes down with the whole thing. Okay, has everybody got that? Parentheses are incredibly important when you're dealing with exponents. So if you finish this problem up, you would have 1 over the cube root of negative 8, and you could leave that out of parentheses there, but then the whole thing is to the 4th power. Okay, so we do that. Now, let's see if we get the same answer. If we do that, what's the cube root of negative 8 now? Negative 2, right? So what you would have is 1 over negative 2 to the 4th. If you worked out negative 2 to the 4th, what you would end up getting is what kind of number? Positive. So you'd actually get 1 over 16. So I want you to notice on that problem, you got 2 different answers. Okay? And they're different problems. It's because of where the exponents are. All right, is everybody clear on that? Okay, you're not going to forget it, right? Okay, figure it out. You got to have a strategy to figure this kind of stuff out. Okay, let's finish up with just these, just down to here. Okay, and then we'll be done. Okay, how are you going to change this to a positive exponent? What would you do? Just go 1 over x to the 5/3. Now that problem you don't need to do anything on because you don't even know what x is, right? You don't know that, so just leave it alone, okay? We haven't done this yet. How do you change this exponent to positive? You bring it to the top, okay? Now you're just doing this backwards. So bring that to the top to make that x to the 4/5, okay? Now, don't get confused about this, but technically this is what's going on this problem. When you move this thing to the top, you really have 1 times x to the 4/5 all over 1, right? There's really a 1 in that denominator, but is a 1 necessary for a denominator? No. So that's why you just write it that way, okay? This one, same thing. What do you do with that x to the negative 2? Where does it go? To the top, okay? So your answer would be 8 x to the 2/9 over 5. You don't know what x is, so there's not a thing you can do. Okay?
We don't have any of these. At least I don't.
You don't have any of these?
Well, I don't have the last one.
Because I gave this handout today, didn't I? Same handout. Oh, maybe the pages got off on this a little bit. Okay? All right, so that'll wrap us up for today.